Okay, so on page 153 in the text, number 135, it reads, when the shot is released at an angle of 35 degrees, its path can be modeled by the formula y equals negative 0.01 x squared plus 0.7 x plus 6.1, in which x is the shot's horizontal distance in feet and y is its height in feet. This formula is shown by one of the graphs A or B in the figure. Use the formula to determine the shot's maximum distance. Use a calculator and round to the nearest tenth of a foot. Which graph A or B shows the shot's path? Okay. And it is y equals negative 0.01 x squared plus 0.7 x plus 6.1. Since it's saying to use a calculator and round the nearest tenth of a foot, we know we're not going to solve this by factoring. Okay, so what formula would we end up using? Quadratic formula, right? Okay. So this is where we start to get into more the advanced topics in the sense that you look at something that's in written form and be able to interpret something and be able to write something mathematically. So if we want to know that its maximum distance, and we're talking about strictly in the horizontal direction, because otherwise we would have to use calculus to determine the actual distance that the shot travels. We're going to talk about strictly horizontal. So we have this going on where it's either going to be, it looks like either going to be this, or it's going to be the same starting point like this. Okay. So if we want to know either this or this, we're not sure which yet, but we want to know this or this. And we can think of, they say the height is modeled by y. Not that. And the horizontal distance is x. So x is the shot's horizontal distance in feet, and y is its height in feet. Okay? So they're both in feet, so that's good. Not to do any conversions. Okay. So if we wanted to know this distance, or this, we're not sure which, what do you think we might do? Where would you think we might start with this? All we know is this is the model of it, and we're not sure, without looking too deeply, if it's this or this. And we want to know, whichever one it is, what is the distance strictly in the horizontal. Okay? Any ideas? Any thoughts? Okay, I'll give you a hint. So, what do we know are one of the coordinates of the ordered pair for this point? And same question for this point here. If I were to write an ordered pair for these coordinates, what do we know? Yes.
Y is 0.
Y is 0, yep. You guys agree that that is on the x-axis, so y would be 0. Okay, so if we know that, think algebraically how we might go from here. If y equals all this in terms of x, yes.
We could just put 0 instead of y.
Yeah, so we're going to now let y be 0, exactly, because we know that's what it is. So let's go ahead and do that. So let's move on to the next page. Make sure you guys are copying this number 2. Keep this. And think that looks like copy. I just duplicated it. Okay, I don't want to do that. So let's do here and edit copy. And go to the next slide. Does anyone not understand why we're letting y be 0 for this problem? Okay. So 0 equals negative 0.01 x squared plus 0.7x plus 6.1. And so now, could we go ahead and apply the quadratic formula as it is now, or do we need to do anything else before we do that? We could do it right now, right? It fits the form, you know, ax squared plus bx plus c equals 0. So we're in that form, so we can now apply the quadratic formula, which, if you guys have a calculator, that's going to come in handy for this one. So we know that x, let's see if we can figure this out, x equals, you guys have it memorized yet? Mm-hmm. 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 And then pretty straightforward from here, right? I think everyone should probably feel comfortable. You're just substituting guys. So what is B? Very good. And what is A? It's different, right? Negative 0.01 and C is 6.1. So let's say we go ahead and we do that. You plug it in. You be very careful of the order of operations, and you get to the end, and you're going to have two. So let's see what happens here. I may need to borrow one of you guys' calculators. So let's do this. So we go. Let's get this one going. So let's go. Let's move this guy. Say right here. I'm going to go ahead and get started. So let's say x equals. You guys agree that b is 0.7 plus or minus the square root of b squared minus 4a, which is negative 0.01, times c, which is 6.1, all over 2a. 2 times negative 0.01. Just make sure when you do this, just make sure, guys, that just plug it in now and just be careful on each step, especially if you're working on math in the morning. Okay, so that looks right. Minus 4ac all over 2a. Okay. So I'm trying to shrink this down. Do some more work on here. I know, Christian, you're in the back. Is this still readable back there?
Yeah.
Okay. All right. So, see, maybe I can try to do some in my head. I really wanted to challenge myself mentally. So 7 times 7 is 49, so 0.7 times 0.7 should be 0.49. 2 decimal places, move it over, so we have 0.49. And now I have minus what will be a negative value. So I'm just going to put a plus and not necessarily worry about the signs anymore. I know it's going to be plus because minus and negative is just change it to plus. So 4 times 6.1 would be 24.4, right? And 24.4 times 0.01, which moved over 2 more places, you have 0.244?
Yep.
0.244. This is all over negative 0.02. So just the left side still the same. All right, keep going from here. We continue this on the next page. Now we're here. And keep going on here. So x would equal, this is where it's going to get really funky here. I'm definitely going to need a calculator for this part. Okay, so 0.49 plus, now if I did 0.5, I'd have what, 0.744 and just deduct one from here. So 0.5 would, what, 0.744? So it should be 0.734? Yeah, okay, thank you. 0.734 all over negative 0.02. Now this, I'm going to definitely, now from here, I don't like to round until the very end. Okay, so now that we're here, I'm going to go ahead and in fact change this to the approximate, because I'm not going to just do this part and then get a rounded value and then take a rounded value and then deduct that or add that to this. I'm going to punch in the whole thing into my scientific calculator or graphing calculator. So let's go ahead and do the negative 0.7 plus the square root of 0.34 all over negative 0.02 and tell me what you get. If more than one person can do it, that would be great, so then we can kind of check each other's work. What is what? 0.734. Where did I get this from? Doesn't have the square root thing? Okay.
I got negative 43.53689.
What is negative what?
Negative 43.53689.
Okay, it's just round the nearest, I think it's the 10th of a foot. So is negative 43.5?
4.
Is it rounded 4? Okay. Okay. So that's one solution. That's when you did addition?
Yeah.
Okay, thank you. And someone else could. It's always good just to check each other. To hear the same, see what we forget the same thing. Did anyone else do this with the plus? You got it, Jerry?
I don't know if that's always plus.
Yeah, this is a condensed way of writing two different solutions, right? One says plus or minus. That's a compressed way of doing negative 0.7 plus square root blah 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 over negative 0.02, comma the other solution negative 0.7 minus square root blah 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 over negative 0.02.
Yeah, I don't say that.
You got the same exact thing as here?
Well, that's rounded, but yeah.
Yes. Okay, good. Great. And then now let's determine the other solution. So now what's great about the scientific calculator, you should be able to go up to, if you put this whole thing at once, you go back up and just overwrite the plus and then make it a minus and hit enter. So, no more additional work. No more work than necessary. Calculator skills are definitely a huge plus. If you have any questions, let me know. What's that? So let's go back to here. Here we have this value minus what would be a negative value.
I see what you're.
So minus negative changes to just plus.
Yeah, with this subtract, it's 42.8 rounded.
42.8.
Yeah.
Did you get the same thing?
About 42.8.
Okay. So this might be where, did one of you do this first, round that, and then go from there, or you did it all at once?
I put all of them.
If you put all at once, you should have the exact same thing.
So when we get into that, we're supposed to square root it before we divide, or?
Yeah. So let's go over, make sure this is very clear. So if you were to do this piece by piece, say, because you're using one on their phone, and that's going to be as convenient as scientific. You would have to do this guy first, whatever that is, because this is technically an exponent, right? 0.734, the square root of that is same thing as 0.374 to the 1/2 power, right? So we would need to take care of this guy first before we do addition or subtraction on the whole top, and then whatever that whole thing is, divide by negative 0.02.
It's 42.14 rounded.
42.14?
Yeah.
And that's what you got? So it'd be 42.1?
Well, it's 42.136, and it goes on.
So at 42.1? Round to the nearest 10? What, here, wait, no?
I thought it was 1 to the next 100.
I thought the directions said 10. It says, use a calculator and round to the nearest tenth of a foot.
Then why did you
Because I'm still waking up. Forgive me. Good point. I didn't even know that's what you're referring to. Alright. Yep, thank you. Okay. So these are our solutions, and I think both of these, I know this one was confirmed, this one was also confirmed. You guys arrived at the same thing, okay? And calculator skills, they're definitely something worth practicing, because once you get comfortable, you want to be comfortable with the tools that you use, whether it be a test in this class, or a test on the ACT or SAT. So, okay, so we have these two solutions, okay? Now, the question is asking, use the formula to determine the shot's maximum distance, and then which graph, A or B, shows the shot's path, okay? So, which one is only one that makes logical sense? Yes. Why is that? Exactly, because of the fact it's positive, yes. So, go ahead and we'll box that. Okay? And you guys might be wondering, why did this even come up? Well, because our model, the model that we originally looked at, looks like this. So if you imagine if each of these continued, they would eventually intercept the x-axis at a negative value, which we're really not concerned about. Okay, we only care about the positive value, so that's correct. Okay. So then the directions, they say, which one it says, which graph shows the shot's path? Okay, so let's look at that. So let's say we have (42.1) and negative 14.1. These would both be the x-intercepts. What's that? Did someone say something? No? Okay. So if you look at the picture in the book, they have a 0, 80, 10 by 0, 40, 10. And I guess that would be the delta that the window is set at. And it comes off at 35 degrees. So if you guys have the book, obviously that's the most perfect picture to look at. Maybe just from that simple fact alone, 35 degrees, what do you think what looks more like 35 degrees if you do have the book in that window, path A or path B, which does look pretty darn close to that. So if you don't have your book, You guys know about what 35 degrees looks like? We should have a good idea, a general idea what 35 degrees. What's 45 degrees, right? What's that? They have them labeled. Oh, okay, on here? Yeah, sorry. So we have, this is path A, and this guy here is path B. So here, and we're talking about, let's say, relative to like a horizontal plane here. What would look closer to 35 degrees? Because we know that, say off to the side here, yeah, let's go with black. If we had a right angle, 45 degrees, if you started, the trajectory started like that, would be exactly halfway between a right angle. That's 45 degrees, right? So 35 degrees should be even less of an angle, yes? So does everyone think that it's B or A? B? You guys see that? Because A looks like it's significantly greater than 45. Maybe even something, this is 90, maybe even something closer to, say, 70 degrees or 75 degrees, somewhere around there.
You draw your horizontal line coming out of.
Of course, yeah, yes. You mean like another one?
Yeah.
Yeah, just to get an idea, yeah. So if we do this,
It's a little confusing.
just to see. Yeah, so that's a good point. So if I have another plane that's parallel to this, another line that's parallel to this line, you can visualize, okay, that trajectory is the same idea. From here or here, because they're parallel, yes. Yep. Okay. And then looking at 136, they just continue on with the problem, and they talk about when it's released at an angle of 65 degrees, which I guess would have been this guy, path A. You have a different model for it, in the same directions. Okay, which I don't think we need to do because I think it's pretty much the same exact process. So 137 is the golden ratio, discussing the golden ratio and golden rectangles, which was part of the extra credit assignment that I let you guys look at. Next section, use the Pythagorean theorem and the square root property to solve exercises 138 through 141. How are you guys with Pythagorean theorem? Really comfortable? Okay, I don't think we'll look at that too much. We'll skip down to sine's area is 54 square feet, find its length and width. Simple word problem here. 147. Let's look at 147. So this is page 154 and 147. 147 reads, a pool measuring 10 meters by 20 meters is surrounded by a path of uniform width as shown in the figure. If the area of the pool and the path combined is 600 square meters, what is the width of the path? So I purposely picked a problem where they give you a diagram. So look at the diagram, look at the information given, and understand that if you're just given the information, if you're just given like the paragraph with no diagram, then you have to be able to visualize it on your own. Okay, and we'll go into one of those as well. If not today, then in the future we'll look at problems where you're not necessarily given a diagram. What's going on? Nothing. Okay, so here we go. So let's go ahead and basically draw what they have going on here. We have this pool, and it's got a border around the pool. And the pool measures 10 by 20. So this is a distance of 10, this is a distance of 20. And it's surrounded by a path of uniform width as shown in the figure. So the uniform width means this distance here it's the same all around. I'm going to say uniform. So we can label this, we don't know what it is, so then that's why we use variables. Since it's all the same, I'm going to use x for all the way around. And then therefore, you guys can see that, as according to the diagram, if this is 20, the actual pool is 20, and we have an x and an x, this length on each, extending the length of the pool, this would be 20 plus 2x. Right? And over here, if this is the width of the pool is 10 feet, and we have an x distance on each side, this would definitely be 10 plus 2x. And what do they want? They want to know if the area of the pool and the path combined is 600 square meters, what is the width of the path? Okay. Okay, so let's write some statements from that. Does anyone know what I might be able to write? If the area of the pool and the path combined is 600 square meters, can I write something from that mathematically?
Yeah.
Okay. Okay.
Can I have a, you see my locker?
Sure. Yeah, go ahead. Yep. So, do we all know what the area of a rectangle is? Right? Can anyone tell me what it is? Yeah? Thank you. Length is width. Length times width. Okay. So let's see if we can write a statement from that. It says, if the area of the pool and the path combined is 600 square meters, and area is equal to length times width.
So you're not.
Okay, good. So substitute 600 for A. Good. If the area of the pool and the path combined is 600 square meters, what is the width of the path? Uh-huh. Yep. And we are looking to, let's remember, what are we looking to find? That's always a good thing to not forget. You say we're looking to find x. Is that the final thing we're looking to find? Is that what they want us to answer? They want us to find with the path. So is that still x? Is that x, the width of the path? Mm-hmm. It is. I want to hear you going confidently, because sometimes what happens is you guys probably didn't get this before. You solve a problem. Oh, I found X and I'm done, but you didn't answer the question. And you had to find maybe something else. You had to find, I don't know, the length of the pool, or the length of the pool, including the path, or something like that. So just make sure that you're answering the question. Okay, so we are definitely, once we find X, we're done. Let's go ahead and select this guy, and let's go ahead and edit and copy and put it on the next page. Find the width of the path. So this here was the pool, right? So if I want to, this here's the pool. That's starting to overflow because of the flood from the tropical storm. Okay, so well, would we have the foil? Yeah, we can. But here's what I want you to understand. You look at it and say, well, it's already factored. Is that convenient? It would be convenient if it was equal to 0.
Can you take out like the forming? Take out or no?
What's that?
You know, like when you, like if you take something out of bowl.
Take something out of both. What do you
Like,
mean?
you know, like there's 2 bowls and 2 10 and then
Oh, okay. I see what you're saying. If we divided, say, each side by 2.
yeah.
Yeah. So I guess we could make it more simple. I like your thinking. So let's make it more simple. So let's do that. Why not? So 600 is equal to what do these two have in common? What's their greatest common factor? 2. So if we take out a 2, we would have 10 plus x.
Yeah.
Can I take out anything out of this guy? I can take out a 2. Okay, and this is all multiplication. And I would be left with 5x. 5 plus x. Good. Okay. Yeah, I like that because then what would we divide or multiply both sides by to make it a little more simple, like, you know, smaller numbers to deal with? Yes?
4.
Yeah, 4. I would definitely do 4 because you have 2 times 2 here, which is 4. And I know that 600 is divisible by 4 because the last 2 digits are divisible by 4. So we'll still have nice full values here. So if I divide this guy by 4, I would get 150. So 150 is equal to 10 plus x times 5 plus x. Is everyone fine with that? That I didn't show actually divide by 4, but I'm actually just dividing both sides by 4. Actually, let me just go ahead and put that so we have it. So divide this side by 4, divide this side by 4.
Where did you get the 4 from?
I got the 4 from 2 times 2.
Okay.
So now we're just left with these two factors. Now, you don't have to do this, but anytime I can make something a little more simple, I will usually do that. We could have gone right into foiling, like you guys had mentioned, go right into foiling and go from there, but, you know, make it more simple, why not? Okay? So do understand that this equation and this equation are equivalent. They're the same thing when you divide both sides by 4. Okay, so now we're here. So what I said before was, it would be convenient, the fact that it's factored, if it was equal to 0, because of the multiplicative rule of 0. Fancy talk for anything times 0 is 0. Right? Because we can say, okay, 10 plus x could be 0, or 5 plus x could be 0. But when they're set to a different value besides 0, we can't just do that or statement. Okay? So we do have to FOIL. Okay, so don't let this fool you that the fact that it's already factored. We do have to FOIL, rearrange things, and then maybe we can factor. We'll see. So let's go ahead and expand this. Let's go ahead and expand this and see what we get. So we have 150 equals, what do you guys get when you FOIL this? 50. So 50 plus 10x plus 5x plus x squared. Okay, so let's keep going. So now you guys see that we want to get, regardless of whether we do quadratic formula or solve by factoring, we need it equal to 0. So let's get there. Okay. So I see like terms here, yeah. That would be 15x. Okay. So let's do that. So let's do piece by piece here. So 150 is equal to 50 plus 15x plus x squared. Yeah, okay. So, I'll make it too small. That's good? Okay. Go away. Alright, so next step. Yeah, I mean, it would be a lot of work, right, to do, okay, let's get rid of all these and make it 0. It's so much easier to just make this guy 0, isn't it? So let's go ahead and do that. So minus 150, minus 150. And so now we're going to have 0 equals negative 100. And I'm going to write it so it's in nice looking descending power. So we have x squared plus 15x minus 100. Yeah, so a quick way to know if you factor it is the discriminant. You guys may have heard that. I think I've even mentioned it before, the discriminant, and that's the part that in the whole quadratic formula that is, that's this guy, the radicand, the b squared minus 4ac, right? Because if that guy is 0, we know we can factor, because we would not have irrational roots. We're going to have nice, well, we can definitely say we won't have irrational roots, but it's still possible we got fractional. So I take that back. If this is 0, our roots will be rational, but they still might be fractional. So we really do have to do the AC method to go through and see if we can factor. So can we factor this? So what factors? Now this is like, I guess what you might call short AC or simple AC, because this guy's 1. We can just look at the negative 100. So what factors of negative 100 could possibly sum to 15 if they exist? We go through them. You can even list them off to the side if that's, if that helps. So the fact that we're dealing with negative 100 are my...
Oh, 50.
Yes?
Negative 20 and 5.
Negative 20 and 5. Negative 20 and 5. What's that?
Positive 20 and negative 5.
Okay, so positive 20
positive 20
and negative 5. So positive 20 and negative 5 give a product of negative 100, but as a sum, they do give a sum of positive 15, so this does work. All right, so we get, okay.
She did it.
Very good. Okay, so, all right, so we can factor, that's nice. We don't have to use it, we don't have to punch in the quadratic formula under a calculator, you do it all by hand, we can go right to it. So we know that 0 is equal to, if I factor this, we're going to get, of course, x and x, and it's 20 and negative 5, so plus 20 and minus 5. And it's always good to quickly always kind of check yourself as you're working. X squared minus 5x plus 20x minus 100. So
x would be negative 25.
yeah, so x could possibly equal negative 20 or 5. Bless you. Okay?
Can we just find one answer?
Okay, so yeah, so this is where we have to, pick the answer, because we're dealing with the problem that's in reality. We're talking about the width of a pathway. Yes?
So it can't be negative.
Exactly same situation as last. We cannot have a negative distance, so the only answer that makes sense to answer the question would be 5, yes. This one does not make sense. We have a few minutes left. Did anyone want to go over any of the homework that was due on yesterday? On yesterday. Did everyone understand that? Everyone got all the... When I give it back to you, I don't pull out. I just go through and just make sure you get it. I might have them in the book. What page was it again? Wait, here it is. Got it. 135. Did they have the solutions in the back for odds?
I honestly don't know.
I honestly don't know either. They are in the back? Alright, he's saying they're in the back. Yeah, that's why, yeah, it's only odds, yep. Yep. And I assigned you just odds.